All right, boys and girls, let's use our good old-fashioned Dixon Ticonderoga number 2 to graph this hotness right here. So this is a quartic at degree of 4. Only has two terms, right? And the leading coefficient's negative. So there's some things we've got to, real simple, but we got to be careful of with this one. So let's go ahead and get started, right? So the degree is 4, and the leading coefficient's negative. So that means that we don't know what's going to happen in the middle, but it's going to be going, down both ways with the degree of 4. The number of turning points will be a maximum of 3, and we could have 4 x-intercepts. Yeah, we could have 0 x-intercepts as well. So, yeah, if the degree is odd, you'll always have at least one x-intercept. But if it's even, then you could have 0, because like it could look like this, and the x-axis could be above it. So always one y-intercept, but yeah, the rest. So let's go and get started. Now, when we put a 0 in for x to find the y-intercept, we can see it goes to the origin, which means that's one of our x-intercepts as well. Now, one thing you always want to do when the leading coefficient is negative is it can make it easy to factor if you take a negative out. So we could factor it beyond this right now, like right off the bat. But just to be careful here, let's take a negative out. So you set it equal to 0, set the equation equal to 0, and then you try to factor it. So we're going to take the negative out because that's going to make things easier. And as far as the x-intercepts, it doesn't matter what this is anymore, because it's negative 1 times. We're going to figure out what this has to be equal to 0. 0 times 1. So it doesn't really even matter. But okay, so negative 1 times, and now look, I can take out of here, I can take out a 2x cubed, and I'd be left with x minus 2. Yep. And so then here's our three factors. We set them equal to 0. So this one right here has, no effect as far as that goes. So 2x cubed equals 0. X minus 2 equals 0. So on this one, you're going to divide by 2 if you wanted. It's going to be 0. So x equals 0. That's this right here. And x equals positive 2. So it looks like we have two x-intercepts, one y-intercept, which is the same, and we know that the graph's going to look something like that. So let's go ahead and sketch it, going down both ways. So here's what we've got. We've got 0, 0, and we've got, let's say that's 2, 0. 2, 0, and 0, 0. All right. And we know it's going down both ways. And here's the deal. It could, because we can have 3 turning points, it could go something like this. 1, 2, 3. It could go something like that. I don't know. So we don't really know what happens in between these two, and we've got to find out. Because we could have 3 turning points, which is enough, 1, 2, 3, to make it work for quartic, or it could just go up. We don't really know. We don't really know what happens in between. All we need to do is find out if in between 0 and 2, if the output is positive, which is above, or negative, which is below. So let's plug in 1. Let's plug in 1. So negative 2 times 1 to the 4th plus 4 times 1. So this is going to be a positive number. Cubed, right? Of course. So this is going to be negative 2 plus 4, which is 2. That's positive. So it's going to be up. Now, I don't really know what happens in between here and here, between here and here. We don't really know what happens up here. We just know it goes up. We don't know how high, anything like that. We just know that it's going to look something like this right here. Now, what we can do is, of course, do our favorite thing, of course, and use Desmos. So let me get my phone ready here. Get my Desmos app on my busted old phone. Now look at that. So sad. So here's what we've got. We've got negative, which I think is down here. Oh, no, that was positive. All right. So I'm going to do it this way. 4x cubed. And then I'm going to do minus 2x to the 4th. And 4. Come on now. So there we go. Yeah. So over here there's like a little hitch. Like in reality, it looks like it went like this and then down, right? But with the math that we have access to, our sketch would be 100% valid and working. So we know what the end behavior was. It's going down over here. It's going down on the right, going down, going down. We didn't know what it looked like in the middle. We just know it's up. So that would be, with what we know how to do with our current math skills, Perfectly valid. Anyway, I hope it's been helpful. Hope you guys are having a wonderful day. I'll talk to you later.